We are going to continue with factoring, and we're going to talk about two very specific types of factoring. The first one is the difference of squares. But before we get into an example of factoring, I'm going to kind of show you a pre-example. And I'm going to multiply these two binomials together. So I'm going to use double distributive. I'm going to take the 3x and multiply everything in the second set of parentheses. So I have 9x squared minus 15x. Then I'm going to take the 5 and multiply that by everything in the second set of parentheses. So I have a positive 15x minus 25. And so if you'll notice, these middle terms, when we go to combine like terms, sort of cancel each other out. And I'm just left with 9x squared minus 25. And so that's going to be the case when we work backwards and we go to factor something like this, if we start with the difference of two perfect squares. So before we get to the actual example, let me just tell you what the rule is. Here's the procedure. So if I have something like a squared minus b squared, and this only works if you have the difference, if you're subtracting the two. If you have a plus sign in the middle, the sum of squares, it's not going to work. So here's the factored form. It's a plus b times a minus b. And that's the factored form. So sometimes it's helpful just to figure out what a squared and b squared are and then find the square roots. So in this first example, a squared would actually be 100x squared, which would make a, if I'm taking the square root of both of these, a would be 10x. B squared is 81, which means if I take the square root of both of those, b would be 9. So I'm just going to literally substitute into this rule here. I'm going to have my two sets of parentheses. So this becomes 10x plus 9 and 10x minus 9. And that's the factored form. Sometimes it gets a little more involved. If there's a greatest common factor, we can factor out first. But that's the gist of factoring the difference of two squares. So here's one for you to try. So then we're going to talk about the sum and difference of cubes. I believe you have not seen anything like this before. And so I'm going to kind of give you the rule first. So this is in the form of a cubed minus b cubed. And we can also, so this one is with the difference, but we can also have the sum as well. And so the rule for this is, excuse me. Okay, we're just going to put a squared, b squared over here, and ab in the middle. And then if you can see down here, we're going to follow this rule of SOAP. And SOAP stands for same, opposite, always positive. And that just tells us how to fill in the signs. So if we have a subtraction symbol, then we're going to follow SOAP. So let me just write the letters down here. So this one's going to be S, this one's going to be O, and this is going to be AP. So when we go to fill in the signs, this is going to be the same as the sign we started with, which is negative. This one's going to be opposite the sign we started with, and this one's going to be always positive. And so we have to figure out what A and B are in order to fill these in. And so if x cubed is really a cubed, so a cubed is x cubed, which means a is x. if you take the cubed root of both sides. That would make b cubed 27. And again, I'm going to go ahead and take the cubed root of both of these. That's a cubed root sign. And so b is actually 3. And if you don't know that the cubed root of 27 is 3, you can certainly figure out in your calculator. I can show you how to do that in class. So then I'm just going to substitute a and b into this formula here. So I'm going to put a right here, b right here, a squared right here, b squared over here, and a times b in the middle. And as you can see, the symbols are already here for us, but it follows SOAP. So this is the same symbol we started with. This is the opposite symbol, and this is always positive. So we're just going to clean this up a little bit and write one more step. All I'm going to do is square that 3. So I have x minus 3, x squared plus 3x plus 9. So here's our answer. I'm going to go through one more of these examples to show you. So I'm going to factor this. This time we have the sum of 2 cubes. And I'm going to follow the same thing. So first I'm going to figure out a and b. So a cubed is actually 8x cubed. And so I'm going to take the cubed root of both, which means a is 2x. B cubed is 125. I'm going to take the cubed root of both of those. So b is 5. So here's the rule again. A, b, a squared, b squared, ab goes in the middle. Then I'm going to follow SOAP. I'm going to start with the same symbol. This is the opposite symbol, and this is always positive. So I'm just going to fill in the terms I already came up with. So a is 2x, b is 5. For a squared, just do the extra step. We're squaring this whole thing. Minus, now I have 2x times 5. And we'll clean this up in a little bit. Plus b squared. And so go the one more step and multiply this out. So this becomes 4x squared minus 10x plus 25. And that is the answer. That's the factored form of 8x cubed plus 125. We'll certainly be practicing this more in class. See you then.